Hey guys, welcome back to another video on making games in GameMaker Studio 2. So this is the first video in my series on making a client-server networking system built on top of GlumiNet. If you don't know what GlumiNet is, it's an asset I just released on the marketplace, and I'll post a link in the description below where you can see a video on where to get that and how to kind of get started. You don't have to go through the whole getting started part of the video if you don't want. Just follow along until you get it, because we're going to be doing basically the same things in that video right now. So I will be coming out after this series is complete with a peer-to-peer networking series to show you how to build a peer-to-peer game on top of GlumiNet. So let me go ahead and show you kind of what we're going to be making. First of all, you see we have this main menu, and actually this isn't all the features we're going to be implementing. We're going to be doing some more stuff in the actual series. So we're going to build on top of this a bit more and go a bit further than this demo shows. I can click host to start a new server, and I can host on a specified port. I can hit F1 and it'll show me some networking statistics. These are given to us by GlumiNet, and I can go to one of my other GameMaker instances and hit join, and I can give it a name like GlumiToad, and I want to connect to port 3000. Successful connection. You can see I'm already synced up with the server, and let me go ahead and join in with another player. I'll just leave this one named player just for the sake of time. And join in, I'll name this like player 2 so you can see that the different names are popping up. So you can see that here we have a server that isn't controlling anybody, and you see all just red players. And all of these other instances actually have a player that is going to be able to fly through the map. And you can also shoot, so I'm going to show you how to use this, and disregard the sound effects. They're pretty bad, but we are going to be using some basic sound effects for the game. So I can fly all these different ships around, watch them all be synchronized, and yeah, it's pretty cool. And if we disconnect, it's going to erase the players from the other instances of the game, and we're left with our lone player. So that's what we're going to be building, and we're also going to be adding some damage and some other fancy things on top of it. So hopefully that kind of excites you, and if you want to follow along, then make sure you get the asset. And if you already have that, let's jump into it. So first of all, you'll need to download the project in the description below. It has some basic stuff set up, like the sprites that we're going to be using, basic object for the button so we don't have to code the button. It's a reusable button, so you could take this object and use it in any of your other projects as well. An empty room, a sound for the laser, so just the really basic stuff. It doesn't even have the networking library in it. So in order to get the networking library in here, we need to go to the marketplace up top, and then we need to go to my library, and then we need to go to GlumiNet. You need to download if you haven't downloaded, and once you have, you just hit import and add all, import, and there we go. Now we have our GlumiNet framework scripts. Okay, so let's kind of talk a little bit about what client-server architecture is, okay? So client-server is basically the concept that all the players connect to a central place, and they all communicate through a central place, which is the server. So clients do not actually communicate directly to one another, right? They're just talking to the server, and the server is kind of communicating between them. So if you want to pass a message on to player 2 and you're player 1, then you send the server the message and you tell them who you're trying to send it to, and maybe the server would then send that to player 2. In addition, the server handles synchronizing everything, or keeping everyone in sync. So if you make a movement and you send that movement to the server, or a request for the movement, we'll talk a little bit about authoritative server stuff later on. We aren't going to be doing authoritative server in this architecture, but I am going to go over that in the future. This is just an introduction to get a client-server system set up, and you can kind of build on top of that. And along the way, I'll be talking about different methods that you could use if you wanted to build your own different like methods that would be used in like a professional game and things like that. The server would receive like your movement data, and then it would relay all that movement or your new position to all of the other peers. So basically on their games and their machines, they're just moving your ship in this instance. So we send our new position to the server, or our inputs to the server, and the server would move us in that case. And then the server every so often just sends everyone an update of the game. So on the server's screen, it's moved all of the players to their new positions, and then it just kind of distributes all of that data to every single player in the game. And then when those players receive that data, they just move that player to the new position. It's really basic, and that's all it is. So a lot of times in this, like I was saying, server authority is used, and that is where you only basically send inputs to the server. Like, so every kind of frame or every so often you'd send multiple frames of data to the server, and that would be like a request. You're saying to the server, hey, I'm pressing these buttons, and then the server would determine where you're moving to. So the server would simulate your movement on its side and then send you back your new position. And there's some issues that go into that we'll talk about in a later video as well, but that's basically how server authority works, is the server actually does the simulation and you're just requesting that the server moves you. And this helps prevent cheating because you can't cheat locally because the server is the final authority. So if the server notices that you're trying to do something that is kind of against the game rules, then it can just not process that piece of data and not send it to you and not update the game state with that request. So let's go ahead and set up our game before we can really get started doing anything else. And how we're going to do that is we're just going to go into our playroom, open that up. And now we are going to just put our buttons in. So open your objects and just drag 2 buttons in here. And these are just going to be our host and our join button. So host is going to start us as a server, and it's going to start listening for connections. And if we hit join, it's going to prompt us for somewhere to try to join an address, and then it'll send the connection. If that connection is successful, it'll move us to the next room. So let's go ahead and specify text. You'll notice the buttons are blank, but this is because I've made these buttons be reusable. So let's go ahead and put text in that we want to use. So I'm going to double click this top one. It's going to be our host button. First of all, I'm going to rename the instance to host button up here. And you might not be able to see well. Can't increase the size, it doesn't look like. And then open up the variables box. So click variables. And you'll notice there's quite a few variables in here. So we could set a different color for our button, all kinds of different things. What we're worried about is this default text. This default text is just the text that's going to be displayed. So this one's going to say host. And then let's give, I guess that's about it. You could specify a font if you wanted, and you could also specify a script that we will be doing in the future. That script gets executed when you click the button. So this is fine. We're just going to change the text. So let's change the text of our bottom one to say, let's say join button as the instance. The reason I'm doing that is because down here you can see that we can reference, or we can see this one's the host button, this one's a join button on our instance layer properties panel. Okay, and now let's go to variables and change the default text of this one to join. And let's go ahead and run the game and make sure it works. So if I hit play, you'll see we have the host and join buttons. And right now we can click and it'll give us an error because we haven't specified a script. Okay, so we have those buttons built now. Now the next thing we want to do is establish a connection. We're going to start talking about how connections work. So first of all, let's define a couple scripts that are going to be used. Let's get out of the GlumiNet framework and let's kind of go to, or create a new group and call it client, let's say client server system, or you could just say game or whatever you really wanted. And now let's create a new script and let's say scr on join, or let's say button join click, and I'm going to duplicate that with Control D, and I'm going to rename this one on host click. Okay, and now these are basically just going to be what gets fired when we click one of these buttons. Let's go ahead and assign these scripts to these buttons. So let's click our host button over here and double click it. I'll just make sure you click the correct one. And then go back to your variables and you have to hit this pencil next to the action on click. This is a script. And then we can select a script now. So if I go here and then I go to our client server system, we want to get the host one. So on button host click, that's fine. Escape. And then click the other one, variables, action on click, on button join, click. There we go. So now those scripts will execute. We could try that again, hitting play, and we shouldn't get errors now when we click. Now the scripts are empty, so they're not doing anything, but now we have somewhere to put our logic when we do click these buttons. Okay, so when we click host, we want it to act differently. We want different behavior from when we click client. So a common practice in client-server networking is to actually make two separate projects, one where all the host logic is in place and one where all the server logic is in place. And the reason for that is because they're handled so much differently. They do completely different things, and they don't really talk to each other within the game logic, okay? So you don't want any of your client-side objects talking to your server-side objects, because the only way they communicate is actually over the network. But we're gonna keep it into one project, and the reason is because if we move outside of the project, move it to two different projects, sometimes there's data that you want to be shared between the two. For instance, we're going to have packet names and packet types for different types of packets. If we had two projects, we'd have to basically copy paste our packet names and packet types to the other project to make sure they stayed in sync. And if they ever did get out of sync, it would be kind of hard to debug, and it would give us some weird issues. In addition, it's really hard to teach using two different instances of the game. And the way that the GlumiNet is integrated, it makes it easy for us to kind of discern logic between the two. And we're going to go over how to handle all that. So let's go ahead and kind of set up our server now. So when we click the host button, we want our server, and I say host, it should just say server, because host can actually mean something else. It can actually mean kind of a server client architecture, but the server is actually another player. So that is another architecture that you could implement that is very similar to this. The only difference is in this one, the server isn't playing at all. It's just kind of managing the game, spectating it in a way. So let's create two objects. So let's go down to our objects and create a new folder. And let's call this, we'll just call this game. And let's go to create object, and let's name this one server manager. And let's create another one and name it client manager. And these may not actually be accurate names, to be honest. Usually you'd name it server and client, but we're going to use client in a different sense. So we're just going to say server manager. It's basically our network manager that is going to be a server, and a network manager that's going to be a client, okay? So we're worried about the host right now. We want to set up our game to be able to receive data from somewhere and set up basically waiting for connections. So let's go ahead and create our server manager on click of the host button. So go back to your on host, click, and we're going to say instance create. We'll just create at the depth. We'll create at -10, -10, or wherever you want. It's going to be invisible, but I like going negative because in this type of game, none of our instances are ever going to go negative. So there's instances and situations that if you're checking for positions of objects and things like that, it could affect it if your controllers are actually like in your game world, okay? All right, and then let's go depth, and we'll just say -10. We are going to be using the server manager and client manager to draw information for us later. And then the object is simply going to be server manager, okay? Cool, so that's all we're doing on host click, and then the server manager is going to handle everything else. Okay, and on join click, we're just going to create our client manager the same way. So we're going to say instance create depth -100, -100, -10, and we're going to say client manager. Okay, so depending on which button you click, one of these guys is going to be created. Awesome. So now on our server manager and our client manager, we don't want them to be destroyed when we switch rooms, okay? Because yeah, we're creating it in this menu, and we have to transition to the playroom, and we don't want that to be destroyed. So how do we do that? Well, we simply just make the objects both persistent. And actually, let's go one step further. Inside of the GlumiNet framework, I've attached a script called assert singleton, okay? And what this does is make sure that only one exists. So we never want to create two server managers or two client managers, okay? We only want one of those guys to ever exist. So we can go ahead and use that. And this will actually do the destroy event and all that automatically. So inside of a create event in our server manager, let's go ahead and say assert singleton. And that's all we have to do. But this actually returns a value. If this object was destroyed, it returns false. And if it gets destroyed, we don't want the rest of this event to happen. So if this does some initialization on different variables, we don't want any of that to happen. We actually want to return. So what we could say is, we could say if not assert singleton, because it's going to return false, then we want to just say return, and it'll exit out of the script. And nothing down here will get executed. So again, this returns false and calls instance destroy. But the rest of this event would actually play out before the instance got destroyed. That's just how it works. But we're going to return out if that is the case. And let's just copy that and put it on the client manager as well. Awesome. So there we go. Next, we want our server manager to initialize the network if we're ready. Okay, so how do we do that? Well, now we're going to get into the GloomiNet stuff. All right, so after the assert singleton, we actually want to open up our network, open up a socket to start listening on. How do we do this? Well, it's pretty easy. We actually just use gnet start network. Okay, now you're gonna see that if we click inside these braces, it asks for some information. The first piece of information that we're gonna have to provide is the maximum amount of connections. So this is gonna be the maximum amount of players you want. Let's go ahead and define that up here. We'll call it max players. Don't make it global or anything, because if you make it global, then it'll be accessible from the client side. And we don't want that, because the clients is going to be treated differently. So make it a instance variable for server manager. So we're going to say max players, and we're going to say equals. Let's allow 5. Let's allow 6 players to make it even in case you wanted to do teams and stuff. So we're going to allow 6 players, and let's just put 6 players as the first parameter there. And now we have to give a protocol ID. And what is a protocol ID? So when we're using UDP, which is what GNet uses, you're just sending a packet to somebody. You don't have to have a connection with them, okay? So GNet actually handles the connection handling for us, and that's kind of its biggest strength, and that's mainly what it is. That's mainly what it's used for, because that is actually a lot of code to establish a connection system using UDP, because all UDP is, hey, I'm sending you a piece of data. If you don't get it, I don't care. Or I do care, I might care, but you don't know if they receive the data, okay? So in UDP, there is no connection. It is something that you have to make up on top of UDP. So protocol ID, what it does, or in this case, what this does, is basically we're giving our packets a signature. So it's any number between 0 and 65,550 or something like that. It's defined in here. All of this code is documented, so you can go read it, but just give a random value that is below 65,500 and you'll be good. This is signing all of our packets that we send. If we receive a packet on this port that we're about to open that does not contain this number at the beginning of it, then we're just going to ignore that packet. Now, that doesn't mean you have to add this manually. This gets added to your packets when you create them, so you don't ever have to worry about this stuff. But when you first create your game and initialize your game, you want to just kind of come up with a random number to make your game a unique signature. Okay, next, we need to define a port that we want to host on, okay? And on a server, you'll want to define a port manually. You can insert -1 and have it kind of open a port automatically, but that isn't best, because if you ever want to host it on another machine and you want people to connect, you have to know what this port is to be able to connect to it for other clients to be able to connect. So what we're going to say is, we're going to use ports. I'm just using 3000 to host on. That's just what I always use, and it works pretty good. And it's never failed me. So 3000 should work. And then let's give it a username, and we're just going to say the username for this is server. This is like your player's username, okay? Now, the GNet start network could fail if this port's not open. So how do we know if it fails? Well, it doesn't actually tell you underneath this. We actually need to get the result. So we're going to save result in this variable, and because this returns a Boolean, true if the network was initialized properly or false otherwise. So we're going to say if result, then we successfully connected or initialized. But we're going to say if not result, then we're going to notify ourselves. So we're going to say if result show message, the provided port may have failed. Let's just say may not be open. Could not initialize network. Okay. And in this case, since every time you click that button, it creates this server manager, let's go ahead and destroy ourselves right here. So we'll just say instance destroy. We're just going to destroy ourselves if it fails. And then when you click that button again, it'll just recreate it and it'll do all this over again. And we'll say if the result was successful, actually, let's go ahead. This is where we're going to like move on to the next room. Okay. So let's go ahead and do that. Let's create a new room and call it RM. Oh, shoot. You notice that I actually messed up. Let's rename the playroom to main menu. And then name the second room to play. Okay, so we're going to say else room go to play. Now, the logic here is kind of backwards. Usually you'd want to do if result, if it's success up top, just to not confuse. You could do that if you wanted. RM play. So we're going to say room go to RM play. Awesome. So let's go ahead and see if that works. And notice this assert singleton actually sets persistent for this object. You'll see it sets persistent there. So you don't actually have to set it explicitly using that function, but we'll go ahead and set it. And now if I hit play and I click host, we should move to the next room if everything works correctly. And allow access is just my firewall saying, hey, this is trying to open up a socket and listen to some stuff. Okay, so there we go. It moved to the next room and we're initialized. Awesome. So that's how we got our server set up. Our server's ready to rock, basically. I mean, that's it. In the next video, we're going to be talking about how to make a connection. We'll be making a connection from our clients to our servers. Awesome. Thank you guys for watching, and I will see you guys there.